All and welcome back to our channel. So today we are going into the world of canvas, and by the end of this video you will understand what canvas is and why it is so important for modern vehicles. And have you ever wondered how different parts of your car communicate with each other, from your airbags to your engine control? It's all because of canvas. So let's get started. So what is canvas? So before going into this definition, I have written like this. Let's imagine your car is like human body, and canvas is like nervous system, and ECUs are your body parts. So now come to this definition. The controller area network is the nervous system which enables communication. The same works in our body. So in turn, nodes or electronic control units, ECUs, are like parts of the body which are interconnected via the canvas. Means these body parts are interconnected to our nervous systems. Okay, so the same way ECUs are connected to the canvas. For car, canvas is a nervous system which information sensed by one part can be shared with another. So if this is a simple example, guys. Take another example. Let's imagine your car as a busy city, let's say Pune or Bangalore. So without canvas, every device would need its own direct line of communication. Means, okay, to every other device. That would be a tangled mess of wires like this. Without tangled mess of wires. So instead canvas acts like a central highway system, simplifying communication. Here you can see, here is a messy wires. Here is, you can see, we are using only single wire. So back to this point. So here, what is an ECU? So with respect to this definition, it is a body parts of the canvas. So here you can see in this image, ECUs are nothing but our node, that is airbag control, engine control, light control. These all are called ECUs. Steering control, brake control, seat belt control, automatic glass control, rain sensor, which I have discussed in my previous videos. So that all are ECUs. So here my question is, how many ECUs a car can support? So you can mention your answer in the comment section if you know. So here come to this diagram. So this blue line, you can see this blue wire, that is our canvas, and to this canvas there are multiple ECUs or node are connected to this central system, which shares information to each other via this canvas. So in a canvas system, each device or node is connected to a central bus. So this bus is like a main road where messages travel back and forth. Each node can send and receive messages, so making the system very efficient. So this CAN bus system is incredibly reliable and ensure that critical information gets to where it needs to go. So for example, if your engine is having a problem, let's say this engine control. So the engine control unit can send a message over the CAN bus. So this engine control unit node is connected to the CAN bus, and it will send a message through this CAN bus. Send a message over the CAN bus to light up the check engine indicator on your dashboard. Dashboard means on car dashboard, like this. If I show you like this, so from here engine control ECU sends a message to through CAN bus to dashboard, so it will display like this. So coming to this where it is, yeah, so here you can see so the CAN bus system, CAN bus systems have two wires. One is CAN high and CAN low. Okay, so in CAN high and CAN low, issues are connected to it. So let's say uh, when any specific issues, like let's take previous example, engine control can prepare and broadcast information. Any information, or any sensor is sending any data, let's say sensor data via the CAN bus. Okay, so which CAN bus have having CAN low and CAN high. So the broadcasted data is accepted by all other ECUs on the CAN network. Here you can see, and each ECU can then check the data and decide whether to receive or ignore it. Here ECU 1 is sending sensor data, broadcasting here ECU 1 is broadcasting sensor data. So here ECU 2 or ECU 3 accept and check whether to receive or ignore that particular data. So this is a CAN bus high low. Now CAN bus physical and data link layer. So in mode here CAN bus physical and data link layer. So it is basically based on the 7 layer of OSI model. Okay, so the CAN bus physical layer defines things like cable types, electrical signal levels, node requirements, and cable impedance. So here baud rate. What is baud rate? So here the speed is measured in baud rate. So CAN node must be connected wire to wire, which I have explained here. CAN high and CAN low. To wire bus with baud rates up to 1 megabits per second, that is classical CAN, or 5 megabits per second, that is CAN FD. And cable length. So cable length means this one, this CAN bus. So cable length means this CAN bus length. So its length is varies between 500 meters to up to 40 meters. And termination means the CAN bus must be properly terminated using a 120 ohm CAN bus termination register at each end of the bus. So speed. So if I talk about the speed of the CAN bus, so high speed CAN bus, which is classical CAN. So it has a speed of 40 kilobits per second to 1 megabits per second. So it provides simple cabling and it is used in practically all automotive application today. So it also serves as a basis for several higher level protocols such as OBD2 and CANopen and many more. So the second generation of CAN is referred to as CAN FD, CAN with flexible data rate. And the second is low speed CAN bus. It has a speed of 40 kilobits per second to 125 kilobits per second. So low speed means so it allows the CAN bus communication to continue even if there is a fault on one of the two wires. Let's say there is a fault in CAN high or a CAN low. CAN high is working and CAN low is not working. In case low speed CAN bus will work. So here hence it is also referred to as fault tolerant CAN. In this system, each CAN node has its own CAN termination in low speed CAN bus. And lean bus, it has a speed up to 19.2 kilobit per second. So lean bus is a lower cost supplement to CAN bus networks. So it has less harness and cheaper nodes. So lean bus clusters typically consists of a lean master acting as a gateway, and it has slave nodes up to 16 nodes. So its example, lean bus example is like AC in our car, or door functionality, opening or closing. So basically it works there. And the last one is automotive Ethernet. So actually this is increasingly being rolled out in the automotive sector to support the high bandwidth requirements of ADAS, infotainment systems, cameras. So automotive Ethernet offers much higher data transfer rate versus CAN bus. So but it lacks some of the safety performance feature of classical CAN and CAN FD. It has a speed. It has a speed of more than it has higher speed than CAN FD and CAN classical CAN, but it has a safety performance issue. So most likely in the coming years we'll see both automotive Ethernet, CAN FD and CAN XL being used in new automotive and industrial development. And next is the future of CAN. So the future of CAN I have already discussed just now. So you can see the benefits, the rise of CAN FD as vehicle functionality expands. So does the load on the CAN bus. To support this CAN FD, which means flexible data rate, has been designed as the next generation CAN bus. Because in automotive Ethernet it has some safety feature issues. So CAN FD will be considered. So this CAN FD has some benefit, like it enables the data rates up to 8 megabits per second versus 1 megabits per second. This is the classical CAN data, and this is the CAN FD data. So it allows data payloads up to 64 bytes, and classical CAN allows only 8 bytes. It enables improved security via authentication. So the next one is how to lock CAN bus data, and the second is CAN database files, DBC file. So for these 2 points I have already covered videos in my Vector CANoe tutorial playlist. So the link is in the description box, so you can refer from there to this one. And if you have any doubts, you can let me know in the comment section. I will reply. So this one I am not going to explain, because practically I have already explained this one. So in that playlist you can find. So next time you drive your car, remember that there is an invisible network like this working tirelessly to keep everything running smoothly, and that's the magic of CAN bus. So here I have covered what is CAN bus, how CAN bus. So here in this video I have covered what is CAN bus, what is an ECU, how CAN bus and ECUs communicate, and if you don't use CAN, and if we use CAN, this is the difference, and CAN high, CAN low. So here one point I haven't covered, that one, how CAN bus internally work. So that I will create a separate video for that one. If I explain here, then video will be long. That's why I have skipped that part, how CAN bus internally works. So there will be a data frame, CRC. So thanks for watching. If you enjoyed this video, make sure to hit the like button, subscribe and turn on notifications so you don't miss any of our future videos.